Hello everyone, welcome to Codecrafters Lab. So today we are going to solve check for prime number from the basic maths in TUF Plus. So let's try to understand this problem. So here we are given with integer n and we need to check if the number is prime or not. If it's a prime, then we will return true, otherwise we will return false, right? Then what is a prime number? So number which has no divisors except 1 and itself, it is a prime number. The number which has like more than 2 divisors like including except the 1 and itself, it is not a prime number. It is called as a composite number. Okay. So here example 1, n equal to 5. It is a prime number. Why it is a prime number? The only divisors of 5 are 1 and 5. Apart from that, we can't divide 5, right? So number 5 is prime. So in case of 8, we have multiple divisors 1, 2, 4, 8. That is not a prime number. So in case of 9, it is not a prime number. So false. So yes, we got our answer. So let's try to understand. I'll get back to the iPad. So here, what we will do, we know, right? What we want to find? We want to find a number which has like more than one divisor or not. So that is like a condition, right? And in case of 1, so let's take 1. So in case of 1 is not a prime number because we can divide 1 by 1. So we can divide it by itself only. We can't divide 1 by any other number. So that's why it's not a prime. It's not a composite, right? But in our case, what we'll do, if n equal to 1, input is 1, then we'll directly return false. Okay. And inside that, so what we will do, we will run a loop from I equal to 2. We don't have to take 1 because it is anyway divided by 1. Any number is divided by 1. So our count is anyway 1, right? And what we will do, I is less than n. I is less than n, nothing but n minus 1. Till n minus 1 we are running loop. From 2 to n minus 1 we are running our loop. So if we find any number between this, like from 2 to n minus 1, if there is any number which is dividing our input integer, then we can return immediately false, because in that case we will have multiple divisors. Not we are not satisfying prime numbers condition, right? So what we will do, if n modulo I equal to 0, if it is there like from 2 to n minus 1, we will immediately return false, right? And we will close this loop, and at the end what we will do, if there is no number as such, we will return true. That means the number is prime. So it is easy. So let's try to code this. So if n equal to 1, we will return false. Then what we'll do, we'll do one for loop int I equal to 2. I is less than n is nothing but n minus 1. Till n minus 1 we are executing this loop. Then inside that, what we'll do, if n modulo I equal to 0, if there is any number between 2 to n minus 1 is a divisor, then we can immediately return false. We don't have to calculate further numbers whether there are any more divisors or not. Otherwise we will return true. Let's try to run this. Yes, it's accepted. And here the time complexity, what is the time complexity? It is O of n. Even if we are reducing two numbers like 1 and n, still n minus 2 is nothing but O of n. So O of n is the my time complexity, and space complexity is O of 1. We don't have any other variable rather than this loop variable, so we can say our space complexity is O of 1, right? but this is a brute force approach. We will try to see optimal approach in the next lecture. Thank you for watching.